So, welcome to this 20th lecture, and first we will begin with in soft note, that is whatever we have done I will try to demonstrate. Nicely it has been prepared by Professor Abhishek Chatterjee, and I want to show you. In this diagram, if you see, this is the B distribution, is not, and B distribution for a 4-pole machine. These 4 poles, how they have been created? It has been created by, there is winding on the stator, and we have seen how to create 4 poles, 2 pole structure like that. 1/4 becomes south pole, 1/4 become north pole, south pole, etc. Therefore, these poles are created by the stator current. And now, on the rotor, which is also an iron, there are only suppose 2 slots. Now, here is a conductor which is perpendicular to this screen, and the front end I call 1, and this is 1 dashed. It is the front end called that is the finish of this coil. So, there is a single coil. Why it is 90 degree, not diametrically opposite? Because whenever 1 is under center of the south pole, it will become 1 dashed must be under the center of the north pole. So, that you get 2 VLV voltage, maximum voltage. In this position, neither of them are. So, 90 degree mechanical is the separation, which electrically means 180 degree. So, outer scale shows the mechanical angle, and electrical angle scale is shown here. So, the coil span is 90 degree mechanical, no doubt 90 degree mechanical, 0 to 90, but it is electrically 180 degree mechanical. And when this coil 1, coil side 1 moves by 360 degree mechanical, you can easily see 2 cycles of EMF will be generated. So, this is the B distribution, space, this is called space. In space, B is changing like this. If lines of force are entering to south pole, I have assigned positive sign. So, only fundamental component we are thinking. So, B max sin omega t, this equation is. Now, if this 1 dashed coil, can they move in different velocities? No. Rotor if moves whatever velocity, they have their position fixed in the slots. Therefore, they will move with the same velocity, and in this developed diagram, it looks like this linear diagrams. But I will not write x distance, because it is all angles I have to correlate with this figure. Now, if it is like this, I will try to sketch what is the voltage across this conductor ends. It could be a multiple turn conductor, several turns, we have seen that. Anyway, this voltage 1, 0, 0 is where? At the back, that is this point is this is 1, this is 0 I am calling. Okay. This is 1, this is 0, this is 1 dashed, this is 0. Because why this is 0? Because it is at the same potential, and this part of this overhang, there is no voltage induced, it is outside the machine poles, this side. So, there will be no voltage induced, assuming that. So, the potential of this point and this point are same, that I am calling O, and this is 1, this is 1 dashed. So, I will sketch E 1 0, and I will sketch E 1 dash 0, and then the voltage across this turn E 1 1 dashed will be nothing but the difference of these two waveforms. Okay. So, let us see what happens if this coil now moves relative to this field is stationary. So, let us see what happens. as time passes E10 will be same as BLV, is not. Similarly, E1-0 will be, only thing its polarity reverses, same type as that of B, it will go, and the difference of these two is this. So, this is BLV, this I have called the final voltage. In that term I have written this will be half half. So, Emax is the voltage across the coil 1 dashed, that fundamental amplitude is Emax. Therefore, each conductor 10 and 1-0 must be halved, that should be 2. So, this is how things goes. Note that I have shown both the angles, this is theta mechanical, theta electrical is, this will be 720 degree, 90 degree is 180 degree, 180 degree is 360 degree. So, when the coil makes a one mechanical rotation, you get 2 cycles of EMF, one cycle of EMF is 180 degree. Therefore, this is how things goes on. This is a very nice demonstration, and you can see this expression also. Okay. Therefore, with this we will now come to our next topics. You keep this look at this demonstration, it will perhaps enhance your understanding. But in spite of all these things, let us come to the lecture part. In spite of all this nice demonstration, you should also mentally think what is going on. This is a good way, a simple way to go back there, but I must also physically know what is happening. Okay, on the coil side it is moving and things like that. So, this is the thing. Therefore, if I neglect the harmonic component and assume the voltage to be sinusoidal, assuming B to be sinusoidal, like this. So, B max sin theta, this is theta electrical, then the voltage across the coil E11 dashed, instantaneous value of the voltage will be also like this. This will be also sinusoidal, which I am writing Emax sin omega t, which of course Emax is that root 2 into RMS value we have calculated, sin omega t. And this I will call it like this, provided I have started counting my time when 1 was here and it is moving towards right with an electrical speed of omega radian per second, that is all. Okay. Now, I mean very roughly sketching the things, if you have a single coil, say 1 dashed, I am sorry, in the rotor there is a single coil. I will not draw the slots, okay. I will avoid drawing this. This is suppose 1 dashed, this is 1, it means slots are there, these are the coil sides, etc. And then your south pole is here. So, one up of this is south pole and it is moving. Okay. It is suppose a 2 pole, this is south, this is suppose north, and this is the RMS voltage. But what happens is this, if you want to get a better voltage waveform, your coil should be distributed. Better do not use a single coil, you use a multiple coil, a number of coils, each one is housed in two pair of different slots and then connect them in series. In which way it will help you? One way is that MMF produced by these coils, when they will carry current, it will be more sinusoidal. I told you it will become stepped. And secondly, the better utilization of this space. So, what I do is this, I have suppose a coil two pole structure I am drawing, 1 dashed, and then I will connect another coil 1 dashed, and this is 2 dashed, and these two coils have their own separate identity with the terminals available to you. Suppose the angle between them is beta, some angle, electrical angle, all angles are electrical now. So, 1 dashed and 2 dashed. Now, I know how to calculate the RMS voltage induced in 1 dashed, and it will be sinusoidal. RMS voltage of 1 dashed is root 2 pi phi, then f, where f is P n by 2, f phi into n. N is the number of turns in 1, there it may be a multi-turn coil, and second coil is identical coil, same number of turns. Then RMS value of 2 dashed will be equal to root 2 pi f, and it is moving in a field created by stator, south, north, etc. It is moving in that field. So, root 2 pi f phi into n. So, RMS values will be same. What will change? What will be the difference between the quality of these two voltages? Nothing really, magnitude E max remains same, but only thing will change when peak value is attained in 1 dashed, the peak value of voltage you get. In coil 2 dashed, that voltage will appear after this angle beta. Therefore, induced voltage in coil 2 dashed will simply lag the induced voltage 1 dashed by some angle, that is all. Henceforth, no point in referring to this fundamental diagram, drawing 2 dashed, moving, trying to understand what is happening, which voltage is leading, lagging, this, that. I only picture this scenario in this way and see the direction of notation, and then I conclude, if this is the voltage phasors of 1 dashed in our phasor diagram, then E 2 dashed will be lagging it. By what angle? By the angle of separation between them, that is the angle between these two slots, that is beta. You know, in case of drawing phasor diagram, this is how we draw. So, it has nothing to do with your rotation of rotor direction clockwise, then why you are drawing, not like that. That is, once this sinusoidal voltage I have got, I can now invoke all the things which I have done in circuit theory, because they are sinusoidal voltages, time varying. So, So, if E 1 1 dashed is here, E 2 2 dashed will be there. Why? Because 1 1 dashed, this is 1 dashed is here and rotor is rotating in this way, and there is identical coil 2 2 dashed housed in these two slots. So, whatever is happening to 1 1 dashed now, same thing is going to happen in 2 2 dashed after this angle beta, where time is there. Beta is the time required by 2 2 dashed to come to this position 1 1 dashed. It can be related with omega t. Therefore, if this is the voltage phasor, E 2 2 dashed will be the voltage phasor of this second coil. Then, if these two coils and this diagram shorthand way of, because after all let us now come out from this very complicated diagram, stator, rotor showing the coils. Okay, coils are physical coils having two terminals 1 1 dashed 2 2 dashed. Only thing I should know how they are positioned in the machine, and from that I have learned that this voltage is E 1 1 dashed, this is the phasor plus minus, and this is the voltage induced in the second coil 2 2 dashed, this is also a phasor. And these two, if you now connect them in series and want to examine what is the voltage E 1 2 dashed 1 to 2 dashed, then that will be simply this one. This is E 1 1 dashed, this is E 2 2 dashed. So, add these two and get the resultant. This will be E 1 2 dashed. RMS values, the length, this will be same because the coil is having same number of turns, rotating with same velocity, moving with same relative speed as 1 1 dashed is doing. Therefore, everything remains same, only thing whatever is happening to 1 1 dash. Now, this is the phasor diagram, mind you, phasor diagram, time phasor diagram. All phasors are moving with speed omega. What is omega? Omega is angular electrical speed per second. Okay? So, this is the scenario. If that be the case, then if you connect another coil, suppose this is 1 1 dashed, one coil, multi turn, n turn, capital N turns. There is another coil, this makes one coil, this is 2 2 dashed, another coil, connect another coil, 3 3 dashed, and suppose the angle between them is all beta, this is also beta, this is also beta. Then how to find out the, so there are now 3 coils, 1 1 dashed, number of turns n, number of turns n 2 2 dashed, number of turns is n 3 3 dashed, and all these suppose are connected in series. So, this voltage is E 1 1 dashed, this voltage is E 2 2 dashed, plus minus, and this voltage is E 3 3 dashed, plus minus. So, resultant voltage which will now be available, only free terminals available is 1 and 3 dashed. So, this voltage plus minus E 1 3 dashed, this phasor will be So first let me draw the phasor. This is E 1 1 dashed. Oh, E 2 2 dashed is lagging E 1 1 dashed by this angle beta. So, this is this voltage E 2 2 dashed, and E 3 3 dashed is lagging by another angle, same angle beta. It could be different angle, then also I will be there is no problem, but let us assume that they are equally spaced like this. Then what is the resultant voltage? Resultant voltage will be E 1 1 dashed plus E 2 2 dashed. So, better way of showing the resultant voltage, because draw a one parallelogram, then that resultant with E 3 3 dashed, it is much elegant way of showing the resultant is the E 1 1 dashed. Now, to this you add E 2 2 dashed such that this angle is beta. I will draw it because space is not there. So, it will be better you will draw it like this E 1 1 dashed. Then you add this voltage E 2 2 dashed, this angle is beta, and then with respect to E 2 2 dashed, E 3 3 dashed is lagging once again by the same angle E 3 3 dashed, and the resultant voltage will be the starting to the finishing point, that is E 1 3 dashed. This voltage will be this length. Each coil this length and this length are all equal. Suppose I want to generate a certain RMS voltage in a machine, okay, and I found out that I require 120 turns, and this RMS voltage can be obtained by only taking two slots and accommodating all the turns here, all 120 turns, that is 1 1 dashed, 2 2 dashed and 3 3 dashed. Each one of them should have 40 turns, and they are all connected in this concentrated, this is called concentrated winding, not distributed. In that case, what is the problem? Problem is that so much of rotor space remains underutilized. So, if coil 1 1 dash, 2 2 dash and 3 3 dash, each one of them is having n turns, n turns, n turns, that is total number of turns are 3 n turns I am using to get a voltage across 1 and 3 dash. Now, suppose somebody says you concentrate all the, forget about this 120 turns, 3 n turns you concentrate here, all the coils you concentrate in these positions. In that case, E 1 1 dashed, E 2 2 dashed and E 3 3 dashed, they will be in phase. So, 1 1 dash, 2 2 dash, 3 3 dash, all are concentrated in two slots only diametrically, provided you have enough space there, let us assume. So, if this thing rotates, all these coil sides belonging to 1 1 dash, 2 2 dash, 3 3 dash, they will have similar voltage, voltages will be in phase. That is why 1 1 dash, 2 2 dash, 3 3 dash will be phase, and therefore, ultimately 2 terminals comes out and resultant voltage will be E13 dashed. So, in a concentrated coil all the voltages are in phase, and obviously this length and this lengths are all equal. I am just imagining, okay, instead of distributing like this, all the turns here, this coil you put in this slot, 2 terminals 1 1 dashed, second coil all the turns you put here only, 3 3 dashed also you put. So, you have put altogether 3 n coils and then connect them in series 1 1 dash, 2 2 dash, 3 3 dashed, and it is then moving in a magnetic field. Therefore, each one of them will have same RMS voltage, their lengths are same, but they will be also in time phase. Whenever maximum occurs to this coil sides, it will occur to all the coil sides belonging to coil 1, 2 and 3. Similarly, this fellow. Therefore, if each of this coil gives a certain voltage, obviously this length O, suppose I call this length to be CD, and here this length suppose I called EF. Obviously, EF is greater than CD, is not obvious reason, because this you are not adding in phase. So, some voltage is always lost. So, this length is less than this length. So, you will get reduced voltage. Therefore, it looks like I want to utilize the periphery of the rotor. I then say, okay, you do that, but you get a reduced voltage. With same number of turns, I could get more voltage if coils were concentrated. That is the idea. But still we go for distributed coils. The reason is clear. Okay, little voltage will be lost. We will find out an expression for that in the later time of the course. But the argument is, okay, this loss in voltage perhaps can be managed, compensated by better increasing the strength of the south pole, north pole on the stator by increasing their excitation a bit, but you get a better utilization of the coil. And second point is, if you want to generate a large voltage, large turns will be required. How can you accommodate all those turns in only a pair of slots? Not at all a practical solution. Therefore, we will use always distributed winding and try to improve upon the nature of B. When these coils will carry current, they will produce B. Let it be more like looks like a sinusoid, and also it is understood that once you distribute the coils, voltage loss will take place, but that voltage loss can be compensated by some other means, like okay, little bit of excitation will increase. Thank you.